Hi, everyone, and welcome to Data Quality Meetup number 6. It's very exciting to have you all. Very excited today to be joined by awesome data professionals. I will introduce them a little bit later in the event. And while we are waiting for everyone to join from all over the world, let's follow our tradition and please post in the chat where are you calling from and what is your favorite OLAP database. We'll start just in about a minute. I see lots of Snowflake fans. Oh, finally someone says BigQuery. Redshift is lagging behind. Awesome. Great, so we will start our first lightning talk in a minute. But for those of you who are joining for the first time, Data Quality Meetup is our virtual event where we bring together the best and most curious data professionals. Some are building tools, some are building teams, some are building data products. And the goal of our meetups is to really learn how to do data better, how to deliver effective, highly reliable data products for our businesses or our customers. And the way we go about these events is we typically have 4 or 5 lightning talks. So those are fairly short 7-minute presentations by our awesome speakers. And then we go into panel discussion where we dive in deeper into a particular topic or explore some of the recent trends that are happening in the data space. We have an awesome lineup of lightning talks today, ranging from building data teams and cultures to enterprise knowledge graphs to modernizing how to operationalize analytical data in production, as well as new approaches to business intelligence. So I'm very, very excited to hear from all the speakers. And to kick off, I would like to invite our first speaker today, Maura George, who is Director of Data Science at Patreon. If you haven't checked out also Maura's awesome team yet, please do so. They are hiring. And Maura will talk about data discoverability in a scaling company. So what do you do to really enable everyone in the organization to use data effectively when the business grows? So I will gently remove others from the stage and leave you, Maura. I'll remove myself as well.
Great. Thanks, Gleb.
So please take it away.
Great. Thanks, Gleb. And hello, everyone. I'm excited to be here. Let me go ahead and share my screen. Let's see if this works. Okay. Great. I think this is working. Sorry, one moment, being the guinea pig here for our first screen share. Okay, so as Gleb said, I am the Director of Data Science at Patreon. I'm going to be talking about Patreon's journey of trying to scale data discoverability as the company has been growing rapidly, and we continue to have a pretty small data science team to support the whole company. So first, just a little bit of context on Patreon and what we're trying to do. Our mission is to fund the creative class, and we think about that as making it so that every creator in the world can make a living from their art directly from their fans via membership. So you may know, if you're a patron on Patreon, or if you know some creators on Patreon, that we have a membership product where, if you're a big fan of Ben Folds, you can pay him $5 a month, $10 a month, and get amazing exclusive live streams and music downloads and a lot more in exchange for your membership. And as a result, hopefully Ben Folds can make money and not have to do as many brand deals or rely as much on advertising or streaming revenue, which generally don't give as much money directly to creators. So the kinds of data we're working with are payments data, as well as general mobile app data like conversion rates and traffic, and then lots of content data, images, posts, videos, audio, tons of user-generated content from creators and their fans. So the team as a whole, right now we have around 300 folks on the team across the globe and 11 data science people supporting that. And we have a full stack data science team. So everything from analytics to data science to machine learning engineering, ops, and BI. And for about 2 years, we've been pretty focused on scaling data discoverability. And so we've been working on this problem for 2 years when we realized, well, the company is growing faster than our data team can support them with all their data questions. So we really need some systems in place to help with this. And there's a pretty wide variety of teams trying to discover data at the business. We have a large go-to-market team with marketing and brand folks. We have a large product and engineering team with about 10 product pods. And then, of course, folks on legal, finance, all the other functions in the company. So I'm going to define a little bit of what I see as the challenge here. I use the metaphor of Sisyphus pushing the boulder up the hill because Sisyphus is generally your data team. And that boulder is things like the constant questions from across the company. Is there an existing dashboard where I can see the breakdown by country of all our creators? Is there a dashboard where I can see how many creators members support on average? Do we know what % of members support multiple creators versus one creator? These are all questions we've gotten in the last 2 months, and these are all available in dashboards across the company, but it's really about how do people find those dashboards, right? They're looking at pinned dashboards in Mode. Maybe they're finding a recent analysis. So I'm not talking as much here about self-service, which I think is a whole other bag of worms, where people are doing their own analysis. I'm really talking about the challenge where you have a ton of data assets, dashboards, analyses, insights, models, and you want your company to find and understand them and use them to make decisions. The other problem we started to have where I really noticed that this was something worth solving is I heard things directly from data scientists like, I'm being too reactive, or I didn't get done any of the work I planned today because I spent the day helping answer data questions, or I wish I could work on bigger analytical projects, which of course is the dream. You hire these really smart people, these data scientists, you want them to be working on rigorous, methodologically challenging analyses. So here's the approach I've taken and the work we've done at Patreon, and it's very much still a work in progress. So I'm excited to chat in the panel potentially about some of the other ideas that people have about this. The first, of course, as data scientists, is to start measuring. And I don't mean measuring in a super discrete quantitative way. I mean just like being aware of the problem and how big it is. So here's what our retro looks like for the team. Every 2 weeks, every member of the data science team says what they accomplished, what their priorities are for the next 2 weeks, and then any call outs on what they expected to do versus what they actually did compared to the previous week's priorities. And this is a time where data scientists can say, hey, I worked on some unexpected work. And some of that might be not related to data discoverability, like, some urgent request came up, but often it's related to like helping people find what they need. The second thing here is to not just point people to the dashboard. I think that often if someone asks a data discoverability question, it's very tempting to just throw them a dashboard link and go on from there. I often feel like this dog in the P.D. Eastman book, Go Dog Go, if you read this in your young years, where this dog goes up and says, do you like my hat? And then this other dog the entire time goes, no, I do not like your hat. And I sometimes feel like that, where I'm like, do you like my dashboard? Look, I have this perfect dashboard for you. And they're like, no, it doesn't really help solve my problem. So really not trying to train people to just, receive a dashboard link from a data scientist or a data person, and really instead try to push them to a behavior where they are going into the space where they can find that for themselves. The third is to build thoughtfully and reference frequently. At Patreon, as I mentioned, we've been thinking about this sort of data discoverability problem for a few years, and we've really started very basic with a paper doc called Data Resources at Patreon, where we collated the most important resources and questions across the business and organized them by theme. So if you had a list, if you had questions about our KPIs, or if you had questions about our creators, you could find that there. And I think the reason it's important to start with this is, there are many tools today, and I think it can be very sexy to like adopt a tool and, throw all the data consumers in your org into a tool. But many people may not find that as friendly as going to a place and a UI they're already familiar with, whether it's Google Docs or Paper Docs or some sort of Slack FAQ. So we started in Paper Docs, and this has been very successful. About hundreds of people across the company use this on a weekly basis. The second thing is really trying to collate everything in one place. I think that data discoverability and really data science can die in DMs. This is the part where I've really started to see the scale break, because you have data scientists that people are used to going to for their questions, and then you have more people join the company and they sort of learn that behavior. And so then you just have your data scientists receiving DMs about data questions all day. So we've started to make these public channels. This is a data manager on my team, Kenna, who said, hey, in an effort to make easier to find everything you're looking for, we have one go-to-market data channel, and it's public, and everyone in the go-to-market team, which is like all of marketing, all of brand, all of account management, all of sales, is in there able to find the questions they're looking for. This helps too, because you often see a question that you might have, and then you can look at that question and see what the answer is, and again, create your own data education out of it. And then, of course, the third, as we've gotten more mature, is to adopt a catalog. And so we use Datafold for our catalog. I know there are a lot of solutions out there for data catalogs. And this is what this starts to look like. So you can look for our core tables within our catalog and see a list of all the core tables that power the majority of our analytics across the company. I'm very excited about sort of the future of the catalog, especially for helping data discoverability for engineers or for folks that are maybe not technical, but very data savvy. If they want to know what's the kind of data we log around currency on Patreon, or what's the kind of data that we have around location, you can just search for location and see all the location data tables. And then finally, don't feign surprise. This is important enough to me that it's actually a norm and a core behavior of our team. There's this great Julia Evans blog post. If you haven't seen it, it also comes from the Recur Center manual. And the idea here is you shouldn't act surprised when people say they don't know something, because it doesn't really help at all. It doesn't have any social or educational benefit. It generally makes people feel defensive and ashamed and somewhat stupid. So even if they ask, how many daily active users do we have? And that dashboard is very discoverable, or you just talked about it at all hands, or you literally just sent them the link yesterday, you don't say, how could you not know that? Because that doesn't create the kind of data culture that encourages questions and encourages folks to continue to ask. And I believe that if you start to stifle those questions, you end up with issues downstream, like people not going to a data scientist when they really do need help for a more challenging problem. So those are kind of the four things I've been working on. Oh, sorry. One more thing is that this still happens all the time at Patreon. Literally last week, my boss said, can you remind me, where can I find the full breakdown of creator categories? And of course, in my head, I was like, how could you not know this? We have this dashboard very readily available. That's not how I responded. I responded with hey, check out this mode link and go/categories. And then really dug into why didn't you self-serve on this? Why didn't you go to GoData or go into mode and look for this yourself? Really trying to get at the root of some of those usability problems of the tools that we do have. A few notes on sort of where I think this is all headed. We've started using the Lineage product and Datafold. And again, I know there are similar Lineage products and other tools. And this is amazing because you can sort of see a map of all your data. But I get really excited about data discoverability as a contextual system where you could say, okay, not only are these the tables, but these are the tables that describe our payments data. And upstream of that, you have all this user behavioral data that generates that payments data. And downstream of that, you have all those dashboards that read that data. And maybe in between, you have a metrics layer, which is, I know, is something we're going to talk about in the panel. And then maybe if you even have a list of questions that are commonly asked, so that if you're a new PM in the payments org, you just go into this contextual data discoverability ecosystem and can find everything you're looking for. And so at the end of Go Dog Go, the dog says, now do you like my hat? I have this big party hat. And finally, the other dog likes the hat. And this is sort of what I dream of, is being able to build at Patreon some sort of contextual data discoverability ecosystem so that eventually it is successful in helping everyone across the company use data very well. So that's it for me. Thank you all so much. And Gleb, I will pass it back to you.
Thanks so much, Maura. This was awesome. And I think we can really ponder on so many things that you've said. I think one big kind of outcome that I certainly took, and I think that I would love everyone to take with them, is that there is so much excitement about tools these days, right? I'm building data tools for a living, but as well. But ultimately, it all comes down to building the right culture and the right processes, because even if you have the smartest tools that kind of index all the data and do lineage, unless you really implement the right behaviors and incentivize the right behaviors within the organization, those tools won't either get adopted, or it's still going to be a very kind of passive and lonely experience for both the data users data practitioners. And I think the other thing that you said, which was data scientists die in DMs, just really strikes close to my heart as a former data engineer at Lyft. And one may always say it's like a death by 1,000 DMs for the data people. So definitely, I think you raised super important questions of how can data teams scale so that they stop being just almost like a support team for answering data questions, but actually drive people to do more data analysis and answering the questions on their own, which is I guess a constant theme within the data professional circles. So thank you so much. And once again, if you haven't been convinced that Maura and her team are awesome, go check out their openings. And I would love to invite on stage our next speakers from Convoy. So Chad and Daniel, welcome.
Hi, everybody.
Hey.
So this is the first time we're actually doing a lightning and thunder talk. So it's a little bit longer than your typical lightning talk. And that's because the topic that Chad and Daniel are going to tell us today is actually very fundamental in so many different ways. So we all heard about the enterprise knowledge graphs hype. We all know how hard it is to standardize analytics, but I've seen very, very few teams out there in the world actually implement anything close, like remotely close to what is hyped as a knowledge graph. And so very excited to hear Convoy's story of how they approached analytics from a more technical infrastructure sense to empower analysts with sort of a single source of truth. Anyways, I think it's hard to put it in a few sentences, and you have to hear from Chad and Daniel, and we'll definitely dig into that topic in our panel discussion. So please take it away.
All right, great. I will share my screen. Oops. All right, cool. We have a lot to talk about, so I'm not going to waste time and just jump right into it. So today we're going to be talking about something called chassis, and that deals with entities, events, and change management. So really quick, a little bit about Daniel and I. My name is Chad Sanderson. I run the product team for data platform at Convoy, and Daniel is one of the lead engineers on the data platform team. So a little bit on Convoy before we jump into the technical stuff. Convoy is a digital freight network. It was founded in 2015. Right now, it's worth about $2.75 billion, based out of Seattle. It is a two-sided marketplace with shippers on one side of the marketplace and carriers or truckers on the other side of the marketplace. We add machine learning and artificial intelligence on top of that framework in order to price, batch, and group loads together. So again, just some context about what the data platform actually is at Convoy. This graph on the right shows all the products and services that we own. We're about a group of around 20 software engineers, data engineers, product managers, and EMs. We have billions of rows of data, which for a company of our size is quite small. But our data is extremely complex, and we have a lot of very complex use cases that we deal with on a regular basis. Our team owns the end-to-end data technology stack, and so that means everything from the source data all the way up to the BI layer, the experimentation, and machine learning layer as well. And as you can see, there's quite a lot of SaaS, open source, and homegrown solutions there. Okay, so let's jump into the core of the problems here and what we're mainly going to be talking about today, which is issues with big data. So one of the first problems and one of the largest problems that we have at Convoy is that we expose our database internals in the data warehouse, but there's not a real contract. We do all this work to basically abstract away implementation details behind APIs, and then we just dump our database content into Snowflake. And that results in a really brittle data warehouse where small changes can easily break downstream consumers. Engineers don't have a lot of visibility into actually who's consuming their data, and adds a ton of complexity into our production systems as well. Our production data model also doesn't represent the real world. So this is a result of basically 5 or 6 years of locally optimal changes. So engineers moving really quickly, building out new services, and not treating data as a first-class citizen. And once again, changes to a service's internal database schema have a really big blast radius. So this is quite problematic. And of course, very hard to change. Our Postgres databases are really great at storing the current state of the world, but not so good about telling us what actually happened in the past. There's a lot of mutable rows, meaning that we overwrite values. And we've tried a bunch of approaches to solve this, everything from like row versioning to using Mixpanel in ways it really wasn't intended to be used, which is quite expensive and slow. And it becomes really hard to answer questions that are conceptually very simple, like how many times did this thing happen? Or how did a particular shipment end up in this state? This is a really important problem for us to solve because there are entire teams at Convoy dedicated exclusively to answering that latter question there. They've implemented a lot of custom logic to figure out how to do this themselves. So in addition to the big data problems, we also have a bunch of big data management problems that are a result of the big data problem. So for example, Snowflake is really messy and difficult to navigate for basically everyone, and that causes a bunch of challenges. We've implemented tools like dbt. We're really heavy dbt users, and so we want to democratize model development. But because our data warehouse is so messy, the mental friction of figuring out where to find things in Snowflake and reuse them is actually lower than the cost of people just building their own models over and over again, which leads to a lot of duplication and makes sort of point number one even worse. We use data discovery tools like Amundsen to help here, but personally, I consider these more like Band-Aids for gunshot wounds. We're making the problem a little bit better, but the fundamental issue still remains. When schemas change, we don't have any good communication channels here besides Slack, and that's pretty spotty. People will miss updates. And SQL queries that were written near Convoy's very early days are total black boxes. There's a lot of institutional knowledge there. They're very brittle. Oftentimes, the person who created them has moved on, but these are still, business critical. So we did a lot of research on this subject. We took about a quarter in early 2021 to take a first principles approach and figure out how we wanted to solve it. And there's a few main takeaways. The first one is we need to start treating our data like a public-facing API. So as Convoy is growing, it's actually no longer feasible to rely on this sort of off-the-books agreement between stakeholders. The second is we need a good mechanism for recording rich semantic events. And by semantic event, I mean some real-world action and not just like a CRUD event. We don't have a very good way, or at least when we produce this, we didn't have a good way of doing it. And that leads to extremely complex queries to infer things that may have happened in the past. The key point is this one. If we can abstract away our analytics data model from our production services, then we're going to radically increase both our engineering and data science innovation velocity. Engineers don't have to worry so much about what's going on downstream, and data scientists don't have to worry so much about this, inferring and interpreting really nasty nested JSON that gets passed from Postgres. So this sort of framework would really simplify a lot of the data science workflow as well. So when I talk about events, especially semantic events, I want to clarify exactly what that means and why events are valuable. So initially, when we think about where we are going to apply events, the focus is mainly on the data warehouse. But there's a ton of other use cases, including service-to-service communication, but we're not quite there yet. We're using the data science initiative as the main push to adopt this type of work. One of those use cases is machine learning, feature computation. So this would allow us to compute point-in-time feature values for training, metrics, which we're going to talk about a little bit later, but it will radically simplify metric definitions, audit logs, and entity histories, so you can figure out what actually happened to in history over some period of time. There's a lot of other things you can do here, like emit events to like a Dynamo database for fast lookup as an example. And then it also facilitates stream processing across, Spark, Flink, KSQL, things like that. So I wanted to add like a really quick example to illustrate what I was talking about on the institutional knowledge of a metric. What you can see on the left here is a BI model that we ran to produce a metric called accept now. That's because we weren't directly emitting any sort of accept now event. So there's a lot of like complex inference logic happening here. We're also, sort of like calling out to a bunch of other BI tables, and none of that's captured. So this query is actually a lot longer than it looks. There's some fuzzy matching going on based on date times. Like it's really, really complicated. And you can see on the right, when we actually have an event called the accept now event, this becomes so much more simpler. And data scientists don't really want to be focused on doing the left. And yet at Convoy, this is something that they spend an enormous amount of their time on. There's not really great monitoring. There's not really great documentation. Ownership falls away, like I said. So this just makes the world a lot nicer for everybody. So the other stage of this project that we focused on was something called the ERD. And this is an abstraction of Convoy's data model. And what that means is we want to define the state of the world that helps data scientists and analysts more easily use these events in machine learning models and reports. And it doesn't necessarily need to map one-to-one to our production data model in Postgres. So that gives data scientists the freedom to define the things that they would use in the ideal world. So if we could go back in time to the inception of Convoy and see the future and say, what should our data model look like, knowing that we're going to have all these products coming in and all of these services, what's the stuff that we would actually care about collecting? And it's made up of sort of three important pieces. The first is this concept of entities. So like a carrier could be an entity or an offer or a facility. It's basically like a independent business unit. Then there are relationships, which is how entities interact with each other. So like an appointment is scheduled at a facility. And then you have events, and events are sort of discrete interactions between entities. So we actually created this over a period of 2 quarters with input from basically everybody at Convoy. This was all the data scientists, the analysts, the entire data team, product managers, engineers, and I realize I should be scrolling through this. And then also even business folks like operations, finance, things like that as well. So we have these 3 very large projects going on consecutively, one of which is the ERD for entity and event documentation, which helps us understand how the business works. Then there's a unified events framework. And this is the mechanism for actually emitting that structured event data to Kafka. So it's just an SDK. Then we have the data warehouse 2.0, and this is for integrating all of this incoming events data. All of these things together represent what we call the events-driven architecture migration. So obviously, if our services aren't like consuming these events, you can't really call it a full events-driven architecture, but that is in the plan, and this is how we refer to it internally. So now what I'm going to do is pass it off to Daniel, and he's going to talk about a really interesting part, another big piece of this project.
Thanks, Chad. So yeah, so we were Chad kind of introed all of these problems that we're having, and we wanted to come up with some sort of solution to help us with this. And our solution that we came up is this internal tool we're calling Chassis. So in looking at some of these challenges at a high level, the first of which is change management. So like, how will the modifications happen to the ERD and to events? We have a tremendous, as Chad mentioned, it took 2 quarters to basically compile this ERD together. How do we make sure that when someone wants to go update it, that is done in kind of a easy manner, so we're not just combing through endless Google Sheets day after day? Also, things like who is responsible for making sure that the definitions of these things is kept up to date and accurate, how will people be kept informed, etc. The second big problem that we ran into is that there are a lot of different systems that we need to coordinate across. So if we define something in the ERD, ideally we want it reflected back into the unified events framework, and also then have it kind of represented in the data warehouse. And then the third one is discovery. So how do we know what events already exist? What data are available for those events? And how do these events kind of relate to these entities? So the goals in formulating solution were basically create a single source of truth for these entity and event definitions. We also want to standardize how we make changes to this entity and events, and also make it accessible so that anyone at Convoy can make changes. We talked about how we got input, not just from software engineers and data scientists, but people on operations, in finance, PMs, etc. And then third, because this process is so complex, we want to automate as much of it as possible to reduce errors. So what did we come up with? What is Chassis? So Chassis serves two core purposes. It is the source of truth. It is the repository for all of these definitions and events, and it is a change management platform. So it seeks to provide a super easy way for people to make changes to the ERD and the events framework. So for change management, like I said, anybody at Convoy can make changes to these entities' events. Each entity and event has an owning team, and also anybody can sign up to be a reviewer if they are a relevant stakeholder. So if you have a content expert in kind of bidding behavior, but they are not necessarily on the team that owns the bid event, they can sign up to basically be a reviewer and review any changes that are made to that event. Once approved, engineers can then take the definition defined in Chassis and incorporate that data using the Unified Events Framework library. Automation is key here, and it provides basically a way to keep multiple systems in sync and monitors for any discrepancies between all of those systems. And at its core, it puts the power to keep definitions in the hands of users as opposed to in like a small group of people who have to make a lot of manual changes. So in terms of where it fits in, we talked about the three big projects. Chassis is basically the glue in the middle here. It syncs all of these things together and basically automates changes across all of these different projects. So why did we come up with this solution? Why did we build it ourselves? So when we were talking to other companies who were transitioning or who had transitioned to event-driven architectures, they talked a lot about the pain points around management and discovery. And so when they were talking about like what we want Chassis to do, they confirmed that like an easy change management system and data discovery would solve a lot of the problems. And we drew inspiration from really good tools like Amundsen, like GitHub, to incorporate kind of the knowledge of what is so good about those tools and how we can apply that to the specific problem that we're solving here. So in terms of automation, we do automation on the validation of production code against event schemas. So as someone is adding events to production services to instrument those events, we do checks to make sure that the data that they are providing to emit in these events matches up with the schemas. We are also basically taking responsibility for updating the data warehouse tables based off of these new definitions. And updating documentation in Amundsen to reflect those changes, and also setting up data monitors on those data to make sure everything is kept in sync. So this is a kind of 9-step workflow of kind of how people normally work. We have people define the data, get approval, update the service, update DBT, make changes in the warehouse, update the documentation, notify parties, set up monitoring, etc. And this whole process in practice takes a lot of time. It takes usually at least a week or so. But with Chassis and the Unified Events Framework, we're basically able to automate the last 6 steps of this process. So we have, you still need to define something, but it's defined in a very clear UI. The approval is streamlined through Chassis. And then engineers just need to go update the service, but everything downstream of that is taken care of by Chassis. So now I'm going to turn it back over to Chad, who's going to walk through a couple of the screenshots of what we've built so far.
Cool. Thanks, Daniel. So I'm going to take you through that UI that Daniel was talking about now. So when we think about where a workflow would start in Chassis, there's a couple different entry points. One is all of this data, the entity data, the event data, and the relationships is represented in a graph. And so we want to make sure that it is discoverable through a graph, and that graph has a good user experience. So through the graph page, people can search for entities, events, or relationships as they please, and they can understand how those entities and events then relate to each other. Another entry point is you can also just search for specific entities or events or relationships directly, or see the ones that were recently modified. Once you choose an entity or event to understand, so this is an example of a shipment entity, we create an abstraction on top of GitHub. And the reason that we did that is because we felt that GitHub was not the right level of ownership for many of the stakeholders for different data consumers in the business. So maybe for data scientists, it could work, but oftentimes for folks that really only know SQL, like certain levels of analysts, it really doesn't. For product managers, it really doesn't. And then certainly for more business folks who also care about these types of things, like on the ops and sales side, it doesn't work at all. So we wanted to abstract that and provide more of a semantic layer where changes to that semantic layer could still be reviewed and approved in the same way a code-based PR would. So you can watch or add yourself as a reviewer to any entity or an event. You can add new events that are related to a particular entity. You can define relationships or even connect those entities to specific tables in the data warehouse for discovery. Then you have the process of actually creating a new change set. And this is the brand new workflow that we're really excited about getting the team to begin implementing. During the process of creating a new feature, while that's happening, we want data scientists and product managers and engineers to collaborate on what is the data I need, what are the new events and entities that I need. They will create those events and entities within Chassis and define all the properties, aka what the schema of that event is actually going to look like. Now, we don't have this. It currently hasn't been, it's on the backlog for some time in 2022. But in order to make Chassis the true source of truth, once somebody creates a event within this framework, we actually want to produce the TypeScript code that then gets used to implement the event in the client side, the SDK for streaming the event to the data warehouse. So the point of this, and I think the takeaway is that we really want to consider data as code. That's something that a lot of people have talked about for a very long time. I think that that's a combination of not just making sure that you can get the data that you want easily, but also making sure that there's a really good process for reviewing changes to the data, making sure that it has great monitoring in place, and making sure that there's hyper clear ownership, which in my opinion is not the state of the world today. So a quick review on what we see the future of Chassis being and sort of where we are right now. We are in full swing of actually implementing these events. So we have an ERD done. We have the SDK that I've mentioned completed. Teams that are all this is actually one of Convoy's largest tech initiatives for 2021 and 2022. So we're swarming on this as an organization, and we've already rolled out a lot of events. Chassis is almost completed. So our goal is to have this finished by the end of Q4 of this year, and then have it ready for onboarding and adoption as teams begin to migrate to this new framework in Q1. And we really want to focus on the onboarding experience of Chassis, as we think it's going to be critical to getting both data science and product teams on board this brand new workflow of thinking about events and thinking about data. So my last one is a pitch. Like, if all this is exciting, please come work with us, because we do have open headcount. And that's it. We're done.
Thanks so much, Chad and Daniel. There is so much material to really dive into and explore, but I think one of the most interesting takeaways here is that this is an example of a project that really fits the trend of seeing data as a more semantic, right? Like, not as just a combination of tables, but actually making our data systems and data platforms much more aware of what is the meaning of the data in the business, and therefore help, making the data platform do more work for people, right? So that people don't have to necessarily keep all the connections and all the meanings in their heads, which becomes really impossible as the complexity of the business grows. So super excited for Chassis, and thanks so much for sharing. So I'd love to invite our next speaker, Benjamin Douglas from Yelp, who is the technical lead, and we'll talk about modernizing business with improved data indexing. Welcome, Benjamin.
Hello, everyone. Just share my screen. All right. Hi, my name is Benjamin Douglas. I am the technical lead for search infrastructure at Yelp, and I'm here to talk to you just a little bit about data hydration. Really quickly, for those of you who are not familiar with Yelp, we're a platform that connects people with great local businesses. This is done primarily through reviews that the users of our platform use businesses and review them on the platform, and use that information to discover other businesses and which ones they want to use. As of last year, we have about 250 million different reviews and 31 million active users. So in short, we have a lot of data and a lot of users that are looking for that data. And that's where the search team comes in. So to give you a little context about what kind of challenges we face, this is a sample search result snippet. Potentially, this was a user who was looking for restaurants or Italian restaurants, something like that. And even though it looks pretty basic, there actually are quite a lot of different pieces of information in this snippet that turns out they come from a variety of different places. So, for example, the name and address and number of reviews might come just out of a single column in a database. But something like the photo to show, which has to be picked from potentially thousands of photos, is a much more complicated process that will involve potentially a machine learned model or fetching data from a number of different databases, et cetera. And essentially what we're doing on the search infrastructure team is trying to make this process as efficient as possible. So it's taking essentially the output of a lot of good work by our data teams for things like the machine learning models and serve them as quickly as possible, basically thinking in terms of milliseconds, like how fast can we assemble this page and display it. So this process has gone through a number of different iterations. The first one was very simple, and we fetched all of the data in real time as the users were asking for it. So in this very simplified flow here, you can see that a user, either from the website or the app, talks to our main microservice, which then calls a subsidiary microservice with all of the logic for fetching the data, applying the models, and so forth. As the models have gotten more complicated and the number of different elements that we show has increased, this has become a bottleneck for showing search results. So we were trying to take a look at how we can speed up this process. The first thing that we tried is sort of what everybody does, is we added a cache. The idea here is that once we have calculated this property for a certain business, we put it into the cache so that if someone else asks for it, they can get the pre-computed version instead of going to the backend databases. Turns out this works pretty well for businesses at the head of the distribution, that is, those that are searched for often. But there's a long tail of businesses that do not get searched for often and that will not end up being in the cache enough to help their performance. So we took a look at this and tried to figure out how can we increase the speed of fetching all of the businesses, not just the ones at the head of the distribution. So what we came up with was essentially a cache with 100% hit rate. That is, we don't actually go and fetch the hydration logic at runtime. We pre-compute it offline so that when a user asks for it, it's already been pre-computed. This is kept alive by having a indexer listen to changes in our SQL backends. And whenever we detect a change in a row in one of the databases, we reissue the hydration logic for that business and feed it into the materialized view. This process has greatly impacted and sped up our fetching time, but operationally, keeping this up and running has been problematic, which I'll explain here. So essentially, we built this up as an ad hoc system that was not integrated with much else inside the Yelp ecosystem. And some of the features that we really wished it would have, and some of these questions that we wished would be easier, simply weren't possible. So with respect to change management, this was a very difficult process, and we had no idea really how to quantify a change in our hydration logic. That would be, for example, a new machine learned model was uploaded, or some logic changes happened. We really had no idea how many properties and in what way that would change. Would we need to backfill, if we had a change in the code, would we need to backfill everything or just some businesses? How many properties are affected, that kind of thing. We just didn't know. And it was a very, it was a process that just required a lot of in-depth information that didn't migrate very well with new people joining the team. There's also no introspection or history into this. The materialized view is a key value store, and all we know is that at any one given time, a certain key has a certain value. We don't know how that changed over time. We don't know at what point it was added. And especially if a row gets deleted, for example, in an incident, if some piece of information is missing, we have no idea when it left. So with all of these problems, we started talking to other groups within the company if they had how they were treating these kinds of issues. And interestingly, it brought us all the way back to our data teams. So there is a pretty sophisticated ETL pipeline that has been built up over the years at Yelp called the Yelp Data Pipeline, that is used primarily for backend and offline data work, things like log processing and collecting data for machine learned models, running those machine learned models, training them, etc. And after taking a look at it, we realized that this would be a perfect fit for our use case as well. So to take a look at the modified architecture, which is what we have today, is that instead of having an ad hoc process feed our materialized view, we actually put it into our production, mostly used for offline data pipeline. There's a lot more information about how the pipeline works on the Yelp engineering blog, but just to give a very brief summary, it is based on Kafka, where the data is flowing from different sources into Kafka streams, and then it uses Flink as a transformation layer to apply transformations to that data, which is exactly the kinds of things that we needed in retrospect. So now that we have this data pipeline in place and a proper ETL pipeline, how has that helped us? Well, the first and biggest thing is that it helped our change management. That it's now much more clear what changes in the code affect which properties and in what way. This is something that we get owing to the organization of the code and how all the data is separated by different streams. The streams are also schematized, which means we know the form of the data and whether something is violating those schemas. And also this process gives us much better tracking of incidents. So for example, we can feed all of this data seamlessly into another data store like Redshift or our data lake and query it for things like, hey, when did this value change and what was the process that made that change, which is something we couldn't do before. And lastly, we have a lot more functionality that our old system didn't give us, things like rewinding it in time and snapshotting it and that kind of thing. Yeah, so that's about it. I just really wanted to go over an example of how some data processing pipelines that normally are associated with offline work have been modified to serve our production traffic. So I definitely encourage you all to go and read more information from our blog, or you can reach out to me directly. Thank you very much.
Benjamin. think that was a really interesting example of, we talked a lot about how production systems influence data and generate data for data pipelines. And I think this was a really interesting application of the analytical data that now influences the production back, right? So now it's sort of like a closed feedback loop. And at every point we have to ensure that the data is, like, the data which is served is high quality. And I think the topic of change management also has been coming up over in pretty much every talk that and discussion that we've had so far. So thanks so much for sharing, Benjamin. And I'd like to invite our last but not least speaker today, Oliver Laslat from Lightdash, who is going to talk about modeling data with metrics. Another deep dive into how to make data smarter and more semantical. So Oliver, welcome, and please take it away.
Okay, we're in business. So I'm going to be presenting a little on the on metrics and the metrics layer and the semantic layer. I'm going to be using those two terms sort of interchangeably. This has already come up a bunch today, and the metrics layer and semantics have been in the news. There was the Looker Tableau announcement, and I feel like a lot of people have been saying, what even is the metrics layer? So yeah, I guess this is less of a deep dive and more of like skirt the surface, simple introduction to what's going on with metrics. So I'm going to try and run to time as well, because I know we're a bit behind. I even have a timer going. So a quick reminder, like why data analysts exist. Why do we get up in the morning? Why do we get the megabucks? The reason is that our companies are kind of getting flooded with this raw data. And this already came up a bunch. Like Chad mentioned, that Convoy, the Postgres database, is like not a good representation of the real world. And so what happens is we have to kind of do analytics to make the raw data useful to the rest of the company. We need the data to be transformed and to be aggregated to ask the kind of questions that people are interested in. So these are usually like, what's the revenue look like? What do orders look like for this quarter? Or how many daily active users do we have? And those aren't looking at individual records, so like a given payment. That's usually aggregations over a whole bunch of data. So we do this analytics and this kind of a presentation layer as well. And that's what it's all about. And once we have that, we have our charts, we can see our profits going up and everyone's happy. So the overall kind of message here is that, like, when we aggregate value together and when we do analytics, we add value to the data and also to the business. So you want to kind of spread data throughout the organization, but like, how do you go about doing that? And I find there's kind of like 3 ways to do it, or like 3 ways that I've seen. So the first thing you could do is you could just give the raw data to the end users. So you just completely like dump them with everything in the data warehouse. And like, this works in a really limited environment where you have a small technical team. And that technical, I'm seeing like a lot of messages, and I'm wondering, is the mic okay? No, fine. I was wondering if my mic was down or something. If you have a really small team and everyone's technical and there isn't that much data, then actually this works kind of well. Like, everyone can write their own SQL and they can query the raw data. But in general, there's a lot of people in the company where it's not part of their job to understand what an inner join is versus a left join and all that kind of stuff. So what companies tend to migrate towards is, well, what if we have a data team that can provide complete answers to the end users? So this tends to be the most common structure, which is that everyone around the company comes to someone with questions. And I think like Maura was talking a lot about this, which is like, we can have pre-configured dashboards for people to look at. And like, we kind of, if they need a change to that dashboard, then that dashboard has to get recreated by an analyst. And usually the kind of upper echelons of management see this as working just like this lorry, that it just drives in, the data team's going to dump a perfectly packaged analysis each time somebody needs it. But if you've been an analyst for 5 minutes, you know that it's way more like this. You're fielding questions from multiple different people constantly. I like this idea that like sharing context dies when it's just done in DMs, and loads of that happens. So you're answering the same question over and over again in DMs, and it's just not scalable. But this is really common. So a lot of data teams feel under stress. A lot of analysts at the moment, they're not super happy because they kind of want to be doing something a bit more in depth, but you're kind of fielding the same questions over and over again. So what if there was a third way, right? Like, what if we could give, and this is where I'm talking a bit about self-serve. Like, what if we could give the data consumers around the business the kind of some meaningful building blocks, and they could take those blocks and piece them together to answer the data questions that they have without having to speak to the data team, but without having to start from scratch, right? Wouldn't that be perfect? And when we talk about the metrics layer, this is kind of what we're talking about. So the one thing to take away here is that a metrics or a semantic layer, what it does is that it gives data consumers around the business some understandable and meaningful building blocks that they can take, piece together in their own way, and use that to answer their own questions. So there's kind of a technical component to that, and also a sort of user experience too. So what could we imagine these perfect building blocks would be like? So I think that these words have already cropped up like throughout the other presentations. But in general, people want to query meaningful entities. So they don't care about like individual tables. They just want to know about emails or orders, transactions, users. So they should be things that mean things to people throughout the business. And then from those entities, you probably want to choose a bunch of relevant metrics. So if it's orders, it's like show me total orders. Maybe I want to split that by geography or filter the data to my relevant business area. But this is just the right amount of flexibility I found for consumers around the business. But like what we don't want to force people to do is joining tables together, having to play with raw data and JSON columns, and definitely not grouping data together, right? So no raw SQL, but querying these would be perfect. And so the metrics layer and the semantics layer, these are generally the keywords that we use to describe those building blocks. So you have metrics, sometimes called measures, dimensions, and filters. And so metrics are basically calculations over entities. So for orders, total revenue. Dimensions would be attributes about those entities, maybe the address where the order was sent or the time at which it was taken. And then filters are attributes we can use to kind of segment the data down to relevant subsets. So let's look at a really quick example. Like here's a common question that might come into the business, to the data team. What is the total order count split by status? So I want to see all of the delivered orders, all the pending orders, the returned orders. And so here, total order count is the metric and status is a dimension. And I guess the entity here would be orders, right? So you take all of the orders, split them by their status, and then just count the number of them in there. And then equivalently, you might imagine that people around the business might want to filter that differently. So I want to see just for customers in Brazil who have placed orders in the last month, for example. And you can imagine this question alone has so many different permutations that people would be interested in around the business. And obviously the way that you get a good feel for data within the company is to kind of fiddle with it and play with it. So with metrics and semantics, what you get to do is just tweak the things that are meaningful for you. So tweak the filters, tweak the metric and the dimension, and not worry about the raw underlying data or the SQL that powers it. So the metrics layer, if there's one thing to take away, the metrics layer and semantics layer maps meaningful words throughout our organization to code that the data analyst can understand. And so the data analysts maintain code, which they love because it's version controlled. It makes sense. It's, it has one definition. And then for the rest of the business and the data consumers, they get to consume metrics that make sense to them, like total order count, status, or customers in Brazil. And everyone's living the dream. So that's how it worked. So now you're probably thinking, where can I get myself a semantics layer? So quick plug, like when I'm not talking about metrics layers, I'm building one with the team at Lightdash. So Lightdash is a BI tool that's completely metrics layer native. So we have our own and we integrate deeply with DBT. So you write your metrics in DBT and we surface up a user experience for people around your business to query common metrics. And since you're here, you can skip the queue for Lightdash Cloud, which is in beta at the moment. So you can join it for free. And all we ask is for some of your feedback. So yeah, hit lightdash.com/DQM. And you can also join us on some of the socials as well. That's it from me.
Awesome. Thanks so much, Oliver. Really, really, really concise and effective presentation of there. And yeah, please go and check out Lightdash. I believe Lightdash is open source also. You have like a GitHub repo that someone can, right? Cool.
Yeah, absolutely. Awesome. Sorry. So maybe I didn't plug hard enough. Yeah, you can catch us on GitHub, download it, launch it, especially if you already have a DBT repo on the go. You just stick Lightdash right on top and you can kind of experience some of this metrics layer goodness.
Awesome. Fantastic. So that's all with lightning talks. I think there's a lot of content to process. and I'd like to invite all of our speakers on stage so we can dig in and double down on a few topics that we've chatted about today. Unfortunately, Maura had to drop for an urgent meeting, but we will certainly share our discussions with her. So Chad, Daniel, Benjamin. Okay, you're here. Nice. Awesome. So I think every data quality meetup, we have a certain kind of theme that is a common thread between multiple lightning talks. And I think today there was a lot of conversations around sort of like smarter semantic data, metrics, ERDs. So I'd love to really dive into that, because not only here, but what we're seeing in the industry is that we have multiple attempts to really rethink how to abstract business logic, how to maybe invent something better than SQL. So Oliver mentioned Malloy, which is the new project by Looker co-founders. There is also some SQL sort of abstraction layers that focus more on data science. There are metric platforms built specifically to kind of compute metrics. We also see solutions like dbt that originally focused on structuring SQL queries and helping data engineers or analytics engineers define and build reliable SQL pipelines, are now also start to think about introducing metric layers to go on top. And so I think the interesting challenge that I haven't really wrapped my head around was that you have these SQL workflows like dbt, right? And you think that, well, okay, maybe the right place for me to define the business logic is there. And then on the other hand, you have those BI tools like, for example, Looker or let's say Lightdash, right? That are also quite rich in their ability to express or define metrics. And so what is the right place to define the business logic? Is there any like line in the sand that we can draw? Like, what is the best practice there? Or do we need a third tool that would not be our ELT framework like dbt, would not be our BI tool like Looker, that would then contain all those metrics and serve them everywhere? I think this is, at least for me, it's like a very big open question that I'm trying to understand. So would really love to hear everyone's thoughts.
I can chime in a little bit on how we think about this at Convoy, and then I'd like to pass it off to Daniel because he's been working on this problem a lot as well. So when we've traditionally thought about metrics, we definitely wanted to abstract them like fundamentally far enough away from data modeling tools like dbt. Because in terms of the stakeholders who care about metrics, it's a lot more than just your data scientist or your analyst. At Convoy, you have ops managers who know very little SQL who care about metrics. There are product managers who care a huge amount about metrics. There's managers who care a lot about metrics. Even executives care about metrics. And the ideal sort of definition surface for us would be something that is version controlled, Git based, but you have the same sort of like ownership parameters and governance parameters as like sort of any other like first class data entity. So we actually built a metrics repository internally that's built on GitHub. It's pretty naive at the moment, and Daniel can talk about this more. But the goal is to abstract away the concept of like a business definition of a metric, and allow there to be some like description and like some semantic meaning of it, and then have a way for that that definition to evolve naturally over time as like different actors want to make changes to it. So Daniel, maybe you'd want to spend just a minute or two talking about like where we are, and then sort of how that thinking maybe is evolving.
Yeah. So we originally actually leveraged dbt in helping to create like the metrics layer using kind of the structure that dbt provides in order for people to define SQL queries, and those represent metrics. It effectively represents this layer not quite down at the source kind of table level, but not high enough at the BI level. It's this kind of layer in the middle that we designed so we can talk to experimentation and we can talk to reporting systems. I think as we had an initial implementation of it, and what we've seen is we really want to make it easy and accessible for anybody at the company to like continue to make changes, which is a theme in Chassis as well. And also really streamline the tools that we use for creating metrics that provide like instant feedback on like, what's this metric going to look like? What are the transformations and things like that. So, yeah.
So if I understand correctly, is there some sort of like a domain-specific language that you have in the platform that helps you define those metrics on top of like those entities that you build, or is it still SQL, just maybe somewhat abstracted away from the sort of messy data prep that happens in dbt?
Yeah, so it's still SQL, and then that SQL is effectively marked up to say like the resulting data that is produced by this query, like what do these things actually mean, and we tie these back to like semantic entities and events and stuff like that. Yeah.
Oh, very interesting.
So that's really curious, and I think that like kind of hits the nail on the head for the metrics, is that they have to be meaningful to everyone, and also everyone needs a way to contribute. And also kind of under the hood, like why not make it SQL? Because like choosing anything else just makes your life much more difficult. Like we like 6 months ago, we decided it would be great to have metrics in dbt. So it's really cool. It's like interesting to hear the other point, that it's better for people not to have to get involved with dbt to do it. The pattern that we were seeing, which might not be true at all organizations, was people who wanted to define metrics maybe didn't have the necessary skills. And this is about data culture, because it sounded like Chad and Daniel mentioned that people were self-serving on dbt models as well. So it sounds like in Convoy, there's like an awesome data culture of people having good data skills and being able to self-serve. Like sadly, it's also not the case everywhere. So usually the central data team ends up being responsible for maintaining the metrics. So one pro about having it in dbt, having it close to the transformation logic, is like that's where the modern data analysts are today. Like these are the tools they hang out in. This is where they feel comfortable. So like marking up and maintaining the metrics there is really cool. I actually agree. If you have a way for business users to maintain those definitions and contribute, then actually I can see that doing that inside of dbt, that's a lot of additional complexity that they don't want to handle. So that's actually really curious.
And so Oliver, so for someone curious about Lightdash, how do you approach the problem? Do you actually define, like, do you assume that you connect to some sort of a data model and then you kind of compute metrics on the fly? Do you define them in Lightdash, or do you define them in dbt? So what is the philosophy that you follow in your product?
Yeah, so the philosophy for us was write them in dbt, make it as thin of a layer as possible on top of the models and on top of the SQL. So push work to dbt where possible. We can manage transformations well, so let's keep doing it. And I was consulting in data before Lightdash, and we saw like some Looker repos get really, really messy. A lot of business logic scattered there, whereas kind of data teams tend to keep their transforms nice and tidy and version controlled. So yeah, the philosophy was keep the metrics layer thin, and that for most data teams, they probably would prefer to maintain that like inside of dbt. And now dbt's actually announced that they're elevating metrics. We kind of existed in this meta tag in dbt, which is kind of like a free-for-all YAML structure. So we injected metric definitions there. dbt have now announced that they're going to kind of upgrade that to a more sort of like first-party entity, which is pretty exciting. So it seems like there's appetite there. I think the one thing I always say about the metrics layer and about all these different implementations that are cropping up is like the benefit of metrics, which Chad and Daniel said, is that the rest of the business can self-serve. So you can build like a really good user experience on top of it. And my fear sometimes at the moment is that like if the metrics layer becomes too generic, it'll be something that more serves the technical teams and doesn't enable us to build really good data experiences on top of it. So there's this like push and pull where like we want it to be really easy for the technical teams to maintain, but simultaneously needs to be opinionated enough to build like data user experiences on top of it. So yeah, it's a hodgepodge at the moment.
Awesome. Benjamin, also curious to hear your point of view here, probably speaking from the largest data scale among all our speakers, right, with Yelp. So curious how, and also I think just as a company and as a sort of data platform, Yelp probably spans, I don't know how many years, right? Probably more than 10, I think. So how that thinking about sort of source of truth, sort of reusable metrics evolved, and how that affects maybe your team's work?
Yeah, no, I mean, I'm definitely coming at it from a little bit different perspective than the rest of this group. I'm not actually on a data team, but I ingest the work of data teams. And it's interesting to hear you talk about adding this like intermediate layer, because like we definitely have a love-hate relationship with that intermediate layer. I mean, even just the example, Oliver, that you showed about like in Brazil means that the lower .locale equals BR. I feel like any one of these decisions has like a lot of, especially corner cases that might come up. And what ends up happening when we look at these sort of more generic metrics, as opposed to like looking at the lowest level, we start to build up an imagination of, I think this is what that means when they say in Brazil, but actually, at the edge, like it might be wrong. And sometimes those edge cases can bite you. So I guess that's just my plea to your side, that I know that there is a tendency to start to add abstractions and make things simpler and easier for people to understand. But if you do that too much, then there's too much of a gap between the people that are using the data and the people that are defining the data, and that you could really, like we've seen it a number of times in various ways, that you can get yourself confused and you can try to be aiming for something when actually you're ending up in a totally different direction.
Yeah, I think it's an interesting point of maybe tension, because I think data teams are now pulled in the directions where they're not just serving analytics, but data is now reused in the production, right? What we've seen with Benjamin, your talk, and I think that creates a lot of pressure to basically, well, not only maintain the infrastructure and do all the computations, but also have, build tools for how those computations are defined and then reused within the organization. So it's a lot of, I think the scope of data teams' work right now is massively getting increased. And it's going to be interesting how that is, like, what is the reaction of organizations and with tooling as well, right? Because even with the metrics platforms that we've seen appearing on the market, some were focused on sort of like, oh, we're just going to give data as an API, basically, metric by dimensions in the JSON format. Some of them were more focused on kind of maintaining the kind of full compatibility with SQL. And I don't think there is yet a really consensus of what is the model that works best. And I think probably we won't come to an answer here with this panel, just given how hairy and big the problem is. But it's really interesting to hear everyone's points of view, right? So the teams building tools internally, teams building tools for others, and the perspective of engineers who actually have to consume some of those metrics and ensure, high availability SLAs. So we are at time, and sadly, I won't go into further questions just yet. We'll leave them for another meetup. I wanted to say huge thanks to all of you, all our speakers who contributed time to talk about your awesome work. I think I personally learned a lot, and I think that everyone who participated have done so as well. And thanks to everyone who dialed in today from all over the world. And we will also share the recordings of the talks and the digests with all the participants and all the speakers, so they can also reshare it within your networks. And we're looking forward to seeing everyone at our future meetups. Thank you, and bye.